Let's continue our exploration of geometry by looking at angles and triangles. If two straight lines meet a third line, and the interior angles on the same side of that third line are less than two right angles, so in this example, theta plus phi is less than 180 degrees, then those two lines will meet if produced on that side. If you extend the lines, eventually they'll meet up. This is the parallel postulate, which is commonly known as Euclid's fifth. Those lines don't exactly look parallel, so why do we call it the parallel postulate? Suppose I have theta and phi, and their sum is not less than 180, so the lines don't meet on that side of the third line. And we saw last time that the supplemental angles are 180 minus theta and 180 minus phi. And suppose the sum of those two angles aren't less than 180, so they don't meet on that side of the transversal. And if you simplify the equation, you see that this tells you that theta plus phi aren't greater than 180. So theta plus phi aren't less than 180, and they're not greater than 180, then theta plus phi exactly equals 180. So the lines don't meet on either side. The lines are parallel. 180 minus theta is the same as phi, and 180 minus phi is the same as theta. We call these angles phi alternate interior angles. They're interior to the two parallel lines, and they're on opposite sides of the transversal. The thetas are also alternate interior angles. That's what we needed for our other form of the parallel postulate, but let's keep playing. We can fill in the vertical angles that we saw before, so there's two more thetas, and now that top left and that bottom right are called alternate exterior. They're on alternate sides of the transversal, and they're outside of the parallel lines. And these phis are also alternate exterior angles, and we call these guys corresponding angles. If you just look at each parallel line in the transversal, you can see that they occupy the same position for each of the parallel lines. Let's focus on the alternate interiors again. And now we're ready for triangles. We want to show that the sum of the measure of the angles of a triangle is 180 degrees. So here's a triangle, and the parallel postulate is equivalent to the following. We call it another version, and it says, given a line and a point not on the line, and by not on the line, I mean even if you extended that line segment in both directions, it's not on that line, then there's exactly one line through the point parallel to the given line. Connect the endpoints of that fixed line to the point, and let's label our angles theta, beta, and phi. We know from earlier that theta plus beta plus phi add up to 180 because they add up to a straight angle. But we also know that if we look at this as parallel lines, that the alternate interior to that theta is this theta. And if we shift our focus a bit and concentrate on this phi, and that orange line is our transversal, then the alternate interior to that phi is this phi. So those angles are the same as well. And now putting that together, since theta plus beta plus phi are 180, since they add up to a straight angle, then what we showed before with the equality of the angles with alternate interiors tells us that the angles in the triangle also add up to 180 degrees. And so the sum of the measures of the angles in a triangle is 180 degrees, and that fell right out of the parallel postulate. Next time, I want to show you another consequence of the parallel postulate. This one has to do with area, and I think it's a bit surprising.